Imagine this with me. You're standing outside on a warm evening. The air feels different, heavy, like something big is about to happen. You look up at the sky and see dark clouds rolling in. Not the usual kind. These clouds look bigger somehow, more powerful. Then you feel it. The first drop of rain hits your face, then another and another. Within minutes it's pouring. The kind of rain that makes you run for cover. The kind that sounds like drumming on a roof. The kind that turns streets into rivers. Now here's where this story gets interesting. Imagine that rain doesn't stop tomorrow. It doesn't stop next week. It doesn't stop next month or next year. That rain keeps falling for 1 million years. I know what you're thinking. That's impossible. How could it rain for 1 million years straight? What kind of world would do that? And more importantly, what happens to everything when the rain finally stops? This isn't science fiction. This actually happened on Earth. And this million-year storm changed absolutely everything about our planet. It created the world of dinosaurs. Without this endless rain, those giant creatures might never have ruled the Earth. Tonight I'm going to tell you this incredible story. A story about rain and fire and the reshaping of an entire planet. A story that takes place so long ago that the world looked completely different than it does today. Before we begin this journey together, I want you to get comfortable. Adjust your pillow, pull up your blanket, let your body sink into whatever you're resting on. This is a long story, and I'll be here with you for as long as you need. If you're using this to help you fall asleep, that's exactly why I make these videos. You might drift off halfway through or near the end, or maybe you'll hear the whole thing. It doesn't matter. Just let yourself relax and listen. And if you enjoy falling asleep to stories like this, maybe hit that subscribe button. I check the comments and it's amazing. People in Berlin having breakfast while someone in Boston is going to bed. All of us connected by these stories. Drop a comment and tell me where you are and what time it is. I love reading them. Now let's go back in time, way back, about 230 million years back. Chapter 2. Standing on a supercontinent picture Earth. 230 million years ago. If you could float in space and look down at our planet, you wouldn't recognize it. All the land on Earth, every single piece, was pushed together into one absolutely massive supercontinent. Scientists call it Pangaea. That name means all Earth in ancient Greek, and it's a perfect name because this thing was enormous. Take every continent we have today: North America, South America, Europe, Africa, Asia, Australia, Antarctica. Now imagine someone pushed them all together like puzzle pieces until they formed one giant piece of land. That was Pangaea. This supercontinent was so big that if you stood in the middle of it, you would be thousands and thousands of miles from the nearest ocean, thousands of miles from water, from moisture, from rain. What do you think that middle part looked like? Desert. Endless desert. The kind of dry, harsh desert that goes on forever in every direction. When land is that far from the ocean, weather patterns can't bring moisture inland. The rain falls on the coasts. The middle stays dry, year after year, century after century, million years after million years. Life in the interior of Pangaea was tough. Only the strongest, most adaptable creatures could survive there. Things like early insects, tough reptiles that needed very little water, plants with deep roots that could find moisture far underground. And there was another group of creatures living on Pangaea, a group that would become very important to our story. They were called archosaurs. You might not know that name, but you definitely know what came from this group. Crocodiles are archosaurs, birds, believe it or not, are archosaurs. And yes, eventually dinosaurs would come from this group too. But here's the thing. At this point in our story, 230 million years ago, dinosaurs were nobody special. They existed, sure, but they were small, not impressive, definitely not running the show. Dinosaurs were just trying to survive like everything else. They had no idea that everything was about to change. They had no idea that deep under their feet something was building, something that would give them the opportunity of a lifetime. But before we talk about what happened to the dinosaurs, we need to understand what caused the rain. And to understand that, we need to look at what was happening below the ground, deep below, where it's hot enough to melt rock. Chapter 3. When Earth decided to change everything. Think about the ground beneath your feet right now, solid, stable, trustworthy. The Earth feels permanent, doesn't it? But here's something that might surprise you. The crust we all live on, this thin layer of rock that holds everything we know, is incredibly thin, vanishingly thin. If you compared the Earth to a peach, the crust would be thinner than the peach's skin. Everything we've ever known, every mountain, every ocean, every forest, all of human history happens in that thin skin. And underneath, heat. Incredible, unimaginable heat. Molten rock flowing and churning like a slow-motion ocean made of liquid fire. Sometimes, deep in the Earth's mantle, huge columns of super-hot material start rising upward. Picture a massive underwater mushroom cloud, but made of molten rock instead of water. These plumes push up against the underside of the crust. They press, they search for weak spots, and eventually they find one. When these plumes break through the crust, something called a flood basalt eruption begins. Now, this isn't like the volcanoes you've seen in pictures. This isn't a mountain that blows its top and causes some damage to the surrounding area. This is different. This is bigger. Much bigger. A flood basalt eruption can release lava continuously for over 1 million years. Let that sink in for a moment. 1 million years of lava pouring onto the surface. 1 million years of the Earth's hot interior spilling out. The results are massive rock formations that we can still see today. They're called large igneous provinces. There's one in Siberia, one in India, and the one that matters for our story spread across what's now Canada and Alaska. It's called the Wrangellia Large Igneous Province. Here's where things get really interesting, and really dangerous. This eruption didn't happen in some empty, barren place. It happened in an area that had huge deposits of coal sitting underground, virgin coal beds that had been there for millions of years, just waiting. Now, you remember the fire triangle from school, right? To make fire, you need 3 things: fuel, heat, and oxygen. When you introduce lava that's over 1600 degrees Celsius to the bottom of a coal bed, you've got the heat, you've got the oxygen, and coal is pure fuel. It's literally compressed plant matter. So the coal started burning, massive amounts of coal, going up in flames on a scale that's hard to imagine, and when coal burns, it releases something into the air, something invisible but incredibly powerful: carbon dioxide. Huge amounts of carbon dioxide. But that's not all. The burning coal also released other gases, nasty ones. One of them was hydrogen sulfide. That's the gas that smells like rotten eggs. And when hydrogen sulfide mixes with oxygen and water in the atmosphere, it becomes something else: sulfuric acid. Think about that. The sky was filling with carbon dioxide and sulfuric acid. The air itself was changing, and this is where the rain comes in. Chapter 4. The fire beneath our feet. Let me paint you a picture of what was happening on Pangaea during this time. Imagine you're an observer from far away. Maybe you're on a spaceship looking down at Earth. You'd see the massive shape of Pangaea sitting in the ocean, and suddenly, in one region, you'd see red. glowing red spreading across the land. The Rangelia eruption had begun. Lava poured out of the ground, not explosively, not violently like you might imagine, just steadily, relentlessly, day after day, year after year. Century after century, the lava spread across the landscape, covering everything in its path. It cooled into black rock, then more lava flowed on top of that, layer after layer after layer, building up into formations that were kilometers thick. And remember those coal beds. They were burning too. Massive underground fires that couldn't be stopped. There was simply too much coal and too much heat. From your spaceship, you'd see smoke rising into the atmosphere. Huge plumes of it. Carbon dioxide and other gases pumping into the air at rates that are almost impossible to imagine. Scientists who study this period found that atmospheric carbon dioxide levels exceeded 1,000 parts per million. To give you perspective, before humans started burning fossil fuels, carbon dioxide levels were around 280 parts per million. Today, with all our cars and factories, we're at about 420 parts per million. But during this event 230 million years ago, over 1,000 parts per million. That's massive. And carbon dioxide is a greenhouse gas. You've probably heard that term. It means that it traps heat from the sun. The sun's energy hits the earth, warms things up, and normally a lot of that heat would radiate back into space. But greenhouse gases trap it, keep it close to the surface. So with all that carbon dioxide in the atmosphere, Earth started warming up. Global temperatures rose by 3 to 4 degrees Celsius. That might not sound like much, but it's enough to completely transform weather patterns across the entire planet. And here's where it gets really interesting. That extra heat had to go somewhere. Energy doesn't just disappear. That would violate the laws of physics. So where did it go? It went into the water cycle. Think about how rain normally works. The sun heats up the oceans and lakes. Water evaporates and rises into the air as invisible vapor. The wind carries this moist air around. Eventually, the water vapor condenses into clouds. The clouds drop their moisture as rain. The rain flows back to the ocean, and the cycle starts over. That's the normal water cycle. But now imagine turning up the heat on that system. More heat means more evaporation. More evaporation means more water vapor in the air. More water vapor means more clouds. More clouds means more rain. And remember those particles from the volcanic eruption and burning coal? Those tiny bits of ash and dust floating in the atmosphere? Water vapor needs something to condense onto to form clouds. Those particles were perfect. So you had more water in the air than usual, more energy driving the system, and more particles for clouds to form around. It was the perfect recipe for rain. Lots and lots of rain. The clouds formed, the winds pushed them inland, and the rain started to fall on the interior of Pangaea, on that ancient desert that hadn't seen significant rainfall in millions of years. And once it started, it didn't stop. Chapter 5. A million years of falling water. Try to imagine this. Really try. You're born in a world where it's raining. Not just today, not just this week, but every day, every week, every month, every year. You grow up hearing rain on whatever shelter you're hiding under. You live your entire life with water falling from the sky. You have children and they grow up with the rain too. They have children. Those children have children, generation after generation after generation, all born into a world where the rain never stops. That's just how the world is. It's raining. It's always been raining. Why would it ever stop? That was life on Pangaea during what scientists call the Carnian pluvial episode. That's their boring name for the million-year rain. Scientists really do have a talent for making incredible events sound dull, don't they? But trust me, this event was anything but dull. The rain fell in waves. Scientists have identified 4 major pulses, 4 times when the rain intensified to absolutely biblical levels. Each pulse probably lasted tens or hundreds of thousands of years. Think about that. A rainstorm that lasts for 100,000 years. Then it eases up a little bit, not stopping, just becoming less intense. Then it ramps back up again for another 100,000 years. 4 times this happened. 4 separate mega monsoons that reshape the entire planet. What do you think happened to all that water? It had to go somewhere, right? It couldn't just sit there on the ground. So it started flowing, seeking the lowest point, carving channels, creating rivers where none had existed before. And because this land had been desert for so long, the ground wasn't ready for this much water. There wasn't much vegetation to hold the soil in place. The water just rushed across the surface, gathering speed, picking up everything in its path. Flash floods were probably common. Massive walls of water racing across the landscape, carrying rocks and soil and anything that wasn't firmly anchored. And remember, this wasn't clean, pure water. This was acidic rain. The hydrogen sulfide in the atmosphere had mixed with oxygen and water to form sulfuric acid, so the rain falling on Pangaea was acidified. When acid rain hits certain types of rock like limestone, it doesn't just flow over the surface. It reacts with the rock chemically. It dissolves it, slowly but steadily. The rain would seep into tiny cracks in limestone formations, drop by drop, year after year, century after century, and those tiny cracks would slowly widen. They'd become channels. The channels would become passages. The passages would become huge chambers. Cave systems were being carved out of solid rock by slightly acidic water, working patiently for hundreds of thousands of years. We can still see some of these caves today. In Britain, there are caves that were formed during the Carnian, dissolved out of limestone by that ancient rain. Meanwhile, all that water flowing across the land was heading for the ocean, and it was bringing everything it had picked up along the way: eroded rock particles, dissolved minerals, dead plant matter, everything. This massive amount of runoff started pouring into the coastal waters, and that's where things got really bad for ocean life. But before we talk about what happened in the oceans, I want to remind you to like this video if you're enjoying the story. It helps other people who love long-form content find these videos too. And if you have thoughts about this ancient rain or questions about dinosaurs, drop them in the comments. What would you do if it rained for 1,000,000 years? I'd love to hear your thoughts. Now, let's dive into the ocean and see what all that rain was doing to marine life. Chapter 6. The Ocean's Quiet Crisis. Imagine you're a fish living in the ocean. 230 million years ago. Life has been pretty good. The water is clear, salty, full of food. The temperature is comfortable. Everything is stable. Then the rain starts. At first it's not a big deal. Rain happens. But then it keeps raining and raining, and you start to notice changes. The water near the coast doesn't taste right anymore. It's less salty. There's fresh water mixing in from all those new rivers that suddenly appeared on land. The water is getting murky too, cloudy with sediment. It's harder to see. The temperature is rising. The water is getting warmer, and warm water can't hold as much oxygen as cold water. You find yourself needing to breathe harder, moving to deeper water where there's more oxygen. If you're a creature that builds a shell out of calcium carbonate, things are getting even worse. The water is becoming more acidic as all that carbon dioxide from the atmosphere dissolves into the ocean, and acidic water makes it incredibly difficult to build shells. It's like trying to build a sandcastle while someone is hosing it down. You're fighting against chemistry itself. About 30% of marine species went extinct during the Carnian pluvial episode. That's a huge number. Entire groups of creatures that had thrived for millions of years suddenly faced collapse. Conodonts, these eel-like creatures with elaborate tooth structures, got hammered. Ammonoids, those beautiful spiral-shelled creatures, took major losses. Crinoids, also called sea lilies, struggled as the water became murky and acidic. Green algae populations crashed. Large areas of the ocean floor became anoxic. That's a scary word that means lacking oxygen, and if you need to breathe, anoxic zones are death zones. Nothing that needs oxygen can survive there. This happens when you have too much organic matter decomposing in the water. Decomposition uses up oxygen. And with all that dead plant material and eroded soil washing into the ocean from land, there was a lot of decomposition happening. Plus, warmer water means less dissolved oxygen to begin with. It's a double hit. Less oxygen in the water naturally, and more of that oxygen being used up by decomposition. So these dead zones spread across parts of the ocean floor. You can see evidence of this in the rock record. Black shale deposits from the Carnian period, indicating oxygen-poor conditions. Fossil assemblages showing mass die-offs. It was rough times if you were living in the ocean. But here's the thing. While 30% of species went extinct, that means 70% survived, and some groups actually thrived. Dinoflagellates, tiny single-celled organisms that are major parts of ocean plankton today, did really well. They're adaptable. They can handle changing conditions. As older, more specialized species died off. These adaptable generalists expanded to fill the empty ecological niches. The ocean ecosystem was being reorganized from the bottom up. The base of the food web was shifting. New types of plankton, new types of small creatures, and eventually, once the rain stopped and conditions stabilized, these would give rise to new types of larger creatures too. Extinction isn't just about death. It's also about opportunity. Every species that died opened up a space for something new, and on land, one group in particular was about to seize their opportunity. But who were these lucky creatures? What made them special? Why were they able to thrive when so many others were struggling? The answer might surprise you. These weren't the biggest animals. They weren't the strongest or the smartest. They were just in the right place at the right time with the right adaptations, and they were about to change the world forever. Stay with me as we meet the early dinosaurs and watch them take over. Chapter 7. When dinosaurs saw their moment, let me tell you about Herrerasaurus. This is one of the oldest dinosaurs we know about, and this creature was no joke. Herrerasaurus was about 6 meters long. That's roughly 20 feet. It weighed over 300 kilograms, about 660 pounds, built like a predator with sharp teeth and powerful claws, muscles designed for speed and hunting. Before the Carnian pluvial episode, Herrerasaurus lived in what's now South America, in an area that was a volcanic floodplain covered in dense jungle. Hot, humid, wet. The kind of environment that most creatures found uncomfortable. But Herrerasaurus loved it. This dinosaur was perfectly adapted for warm, humid conditions. That was its ideal habitat. Now remember what was happening during the million-year reign. The climate across Pangaea was changing. The dry desert interior was getting wetter, warmer, more humid. Jungle-like conditions were spreading from the coast deeper and deeper into the continent. Do you see where this is going? Herrerasaurus's perfect environment was expanding. That warm, humid jungle habitat that used to be confined to small pockets was now spreading across huge areas. So these dinosaurs started expanding their range. They pushed into territories that had been inhospitable desert before. And when they got there, they found something incredible. The competition was gone. The creatures that used to dominate those areas, the ones adapted to dry desert conditions, they were dying off. They couldn't handle the new wet climate. The ecological niches were empty. The food sources were available. It was like Herrerasaurus walked into an all-you-can-eat buffet with no line, and Herrerasaurus wasn't alone. Other early dinosaurs were having the same experience. Everywhere the rain transformed the landscape, dinosaurs found opportunities. Here's a thought-provoking question for you. Was it intelligence that let dinosaurs succeed? Was it strength? Or was it just luck? Being adapted to the right environment at the right moment in history. How much of success is skill versus being in the right place at the right time? It's something worth thinking about, for dinosaurs and for us. We actually have evidence of this dinosaur takeover preserved in rock. In what's now Italy, in a region called the Dolomites, scientists found thousands of fossilized footprints from this time period. These footprints were laid down over about 3 to 4 million years, spanning the Carnian pluvial episode. And when you look at these footprints chronologically, you can watch the dinosaur revolution happen in real time. Before the rain started, dinosaur tracks are basically absent. You see footprints from all sorts of other creatures, but dinosaurs barely show up, maybe a few % of tracks at most. Then the rain starts and the ratio begins to shift. More and more dinosaur tracks appear in the record. By the end of the Carnian pluvial episode, dinosaurs are making up over 90% of the fossilized footprints. 90%. That's not just success, that's total ecological dominance. Think about what that means. If you could travel back in time to the end of the million-year reign and look at fresh mud on the ground, 9 out of 10 footprints would belong to dinosaurs. Everything else had been pushed to the margins. Dinosaurs had won. Scientists found the same pattern in other parts of Pangaea, in what's now Central Europe, in Argentina. Everywhere they looked, the story was the same. Dinosaurs went from being minor players to running the entire show. And it all happened because of the rain. That million-year storm that transformed the planet gave dinosaurs their shot at the big time. But here's something that might make you pause. This was one of the biggest extinction events to hit the oceans. 30% of marine species died. The climate changed dramatically. And yet, overall biodiversity on Earth didn't really decrease. How is that possible? How do you have an extinction event that doesn't reduce biodiversity? Drop your thoughts in the comments. What do you think was happening? It's one of those mysteries that makes you question what we even mean by extinction. The answer is that the Carnian pluvial episode was less of a pure extinction event and more of a reorganization, a reshuffling of the deck. Yes, species died, but new species evolved to take their place, and in many ways, there ended up being more diversity after the rain than before. Desert specialists died out. Humid environment specialists thrived and diversified. The total number of species might have even increased. The biosphere was richer and more complex after the Carnian than before. It was the perfect size catastrophe. Big enough to cause major changes, but not so big that it killed everything. Chapter 8. Footprints in Time. Those footprints in the Dolomites tell us something profound about this moment in history. They're not just evidence of dinosaurs, they're a record of a revolution. You see, bones tell us what died in a particular place, but footprints tell us what was alive and active. What was walking around, hunting, migrating, raising babies, living. Every footprint is a moment frozen in time. An animal stepped in soft mud. The mud dried, more sediment covered it. Over millions of years it turned to stone. and now we can see that exact moment preserved forever. When you look at those layers of footprints spanning millions of years, you're watching a story unfold. The story of how dinosaurs went from occasional visitors to complete masters of the landscape. The first layer, mostly other reptiles, a few early mammals, the occasional dinosaur track, rare enough to be notable. The next layer, more dinosaur tracks, still outnumbered but increasing. The layer after that, dinosaurs making up maybe a quarter of the tracks. They're showing up more regularly now. The next layer, half the tracks belong to dinosaurs. They're becoming the new normal. And finally, 9 out of 10 tracks are dinosaurs. They're everywhere. They've won. It's one of the most dramatic takeovers in the history of life on Earth, and we can watch it happen, layer by layer, footprint by footprint. What impresses me most is the timeline. This didn't happen overnight. It took millions of years, but in geological terms that's remarkably fast. The dinosaurs went from underdogs to champions in what was basically a blink of the Earth's eye. And here's something else interesting. The diversity of dinosaur tracks increases as you move up through the layers. At first it's just a few types, but by the end there are many different kinds of dinosaur footprints, different sizes, different shapes, different patterns of movement. That tells us the dinosaurs weren't just increasing in number, they were diversifying, evolving into different species, adapting to different lifestyles and ecological niches. Some dinosaurs were becoming herbivores, eating the plants that now grew abundantly across the humid landscape. Others remained predators, hunting the herbivores. Some were getting bigger, others stayed small and nimble. The dinosaur family tree was branching, growing more complex, developing the incredible variety that would characterize the age of dinosaurs for the next 150 million years. And all of this was being driven by the opportunities created by the rain. That million-year storm had transformed the planet and given dinosaurs a blank slate to work with. But here's a question worth pondering. The rain eventually stopped, right? After over 1 million years, it finally ended. So what happened then? Did dinosaurs lose their advantage when the climate changed back? Did the old species return and reclaim their territories? The answer is no, and that's important. Once dinosaurs had established themselves and diversified, they didn't give up their dominant position just because conditions changed again. They'd evolved, they'd adapted, they'd spread across the entire supercontinent. Even when the mega monsoons ended and some areas dried out again, dinosaurs remained in control. They'd outcompeted their rivals so thoroughly that there was no going back. The world had been remade, and dinosaurs were here to stay. If you're enjoying this journey through deep time, consider sharing this video with someone who loves dinosaurs or natural history. These stories are too amazing to keep to yourself, and I promise they'll thank you for introducing them to the tale of the million-year reign. Now let's talk about what the world looked like after the rain finally stopped. Chapter 9. The World That Emerged. After over 1 million years, the Wrangellia eruption finally ran out of steam. The magma stopped flowing at the same rate. The coal beds burned themselves out or were no longer being heated by fresh lava. The rate of greenhouse gas emissions into the atmosphere started to decline. It wasn't sudden, it was gradual, but the trend was clear. Less carbon dioxide being added to the air, and once emissions declined, the carbon cycle started working in reverse. All those plants that had been thriving in the warm, wet climate were pulling carbon dioxide out of the atmosphere through photosynthesis. They were using it to build their leaves and wood and roots. When these plants died and got buried, that carbon was locked away. Some of it would eventually turn into coal again, the same coal that might be burned by another volcanic eruption millions of years later, or by humans in the distant future. But in the shorter term, the plants were acting as a carbon sink, removing CO2 from the atmosphere faster than it was being added. Atmospheric carbon dioxide levels started to drop. The greenhouse effect weakened. Temperatures began to decline back toward previous norms, and as temperatures dropped, the water cycle slowed down. Less evaporation meant less atmospheric moisture. Less moisture meant less rain. The mega monsoons tapered off. The fifth pulse of rain that you might expect based on the pattern of the previous four, it never came. The system was winding down. The planet was reaching a new equilibrium, but it wasn't the same equilibrium as before. Too much had changed. The landscape had been physically reshaped. New river systems had been carved. New caves had been hollowed out. Coastlines had shifted as erosion redistributed sediment. The ecosystems had transformed even more dramatically. The species composition was completely different. Dinosaurs were everywhere, occupying niches that had belonged to other groups before. You couldn't go back to how things were. The old world was gone. A new world had taken its place, and this new world belonged to the dinosaurs. From the end of the Carnian pluvial episode until the asteroid impact 66 million years ago, dinosaurs would rule the Earth. That's 150 million years of dominance. To put that in perspective, the entire age of dinosaurs was 150 million years long. Modern humans have only existed for about 300,000 years. Dinosaurs ruled for 500 times longer than humans have existed. Let that sink in. They were astoundingly successful by any measure, and it all traces back to that rain. That million-year storm that gave them their opportunity. The forest that grew during and after the Carnian formed the basis for Mesozoic ecosystems. Ferns and conifers spread across regions that had been barren desert. The character of plant life on land shifted dramatically. Insects diversified. More plants meant more food for herbivorous insects. More herbivorous insects meant more food for predatory insects. Dragonflies probably did really well in all those new wetlands. Beetles evolved into countless new forms. In the oceans, the species that survived the Carnian went on to repopulate the seas. New types of fish evolved. New types of marine reptiles appeared. The food web was rebuilt from the bottom up. Life found a way. It always does. Even after catastrophe, even after mass extinction, life adapts and carries on. The Earth that emerged from the million-year rain was fundamentally different from the Earth that existed before, but it was still teeming with life, still dynamic and complex and beautiful in its own way. And this brings us to an important question. What does this ancient event teach us about our world today? What can a 230 million-year-old rainstorm tell us about the challenges we're facing now, more than you might think? Because the mechanisms that drove the Carnian pluvial episode are the same mechanisms driving climate change today. The details are different, but the fundamental processes are identical. Stay with me for this final chapter as we connect the ancient past to the present and think about what the million-year rain means for us. Chapter 10. What this ancient rain teaches us today. Here's something that might seem strange. The Carnian pluvial episode and our current climate situation have a lot in common. Both involve pumping massive amounts of carbon dioxide into the atmosphere. During the Carnian, it came from volcanic eruptions and burning coal beds. Today, it comes from power plants and cars and factories. The source is different, but the gas is the same. Both involve the greenhouse effect. Carbon dioxide traps heat from the sun. That extra heat supercharges the water cycle. You get more evaporation, more atmospheric moisture, more extreme weather events. Both involve ocean acidification. When CO2 dissolves in seawater, it forms carbonic acid. The ocean becomes more acidic. Creatures that build calcium carbonate shells struggle. The parallel is almost eerie. It's like we're running a smaller, faster version of the Carnian pluvial episode. The big difference is the timescale. The Rangelia eruption released its carbon over 1 million years. We're releasing comparable amounts in just a couple of centuries. The system doesn't have time to adjust gradually. Species don't have time to adapt slowly. Ecosystems can't reorganize themselves over millions of years like they did during the Carnian. Everything is happening faster than natural rates of change, and that's what makes it challenging for life on Earth today. But the Carnian also offers some perspective. It shows us that Earth has survived far worse than anything humans can throw at it. The planet will be fine in the long run. Life will continue. Evolution will carry on. It's not the Earth we need to worry about. It's us, and all the other species currently living. The planet has this remarkable ability to heal itself, to adapt to new conditions, to continue supporting life even after catastrophic events. Give it enough time, and Earth will bounce back from almost anything. The question is whether human civilization can adapt fast enough to the changes we're causing, because the planet will move on with or without us. The Carnian teaches us something else too, about extinction and opportunity. Every species that went extinct during the Carnian opened up space for something new. The extinction of desert specialists created opportunities for humid environment specialists. Extinction isn't just about death, it's about transformation, the reshuffling of life's deck. It's cold comfort when we're talking about losing species we love, but it's the reality of how evolution works, and here's perhaps the most important lesson from the Carnian. Success often comes down to being in the right place at the right time with the right adaptations. Dinosaurs didn't succeed because they were inherently superior to other creatures. They succeeded because they happened to be adapted to humid conditions at the exact moment when humid conditions spread across the world. It was timing and luck, and being able to seize an opportunity when it appeared. That's true for species, and maybe it's true for civilizations too. We're living through our own moment of dramatic change, climate shifting, ecosystems transforming, some species declining while others adapt. The deck is being reshuffled again. The question is how we'll respond. Will we adapt? Will we mitigate the changes we're causing? Will we find opportunities in the disruption, or will we be among the casualties? The Carnian pluvial episode reminds us that change is the only constant on this planet. Earth was different in the past. It's different now. It'll be different in the future. The question isn't whether things will change. They definitely will. The question is how we'll respond to the changes we're experiencing and causing. 230 million years ago, a geological accident gave dinosaurs their shot at dominance. They took that opportunity and ran with it, becoming the most successful large land animals in Earth's history. 180 million years later, another accident ended their reign and gave mammals their chance. And here we are, the descendants of those opportunistic mammals, now shaping the planet ourselves. We're writing the latest chapter in this ongoing story of change and adaptation, and extinction and evolution. The rain that fell for 1 million years changed everything. It reshaped the land, reorganized ecosystems, set the stage for an entire era of Earth's history. And in doing so, it reminds us that our planet is dynamic, always changing, always adapting, always moving forward. The story never ends. It just continues with new characters, new challenges, new opportunities, and who knows, maybe millions of years from now, some future intelligence will look back at our time and wonder about us the same way we wonder about dinosaurs. What gave us our opportunity? How did we respond to the changes we faced? What kind of world did we leave behind? The answers to those questions are still being written by us right now. Just like that ancient rain rewrote the story of life on Earth, our actions today are writing the next chapter. What will it say? That's up to us to decide. Thank you for spending this time with me tonight, exploring the deep past and thinking about what it means for our present and future. If you made it all the way to the end, you're one of the real ones. Drop a comment and let me know. And if you drifted off somewhere along the way, that's perfect too. That's exactly what these videos are for. Sweet dreams, wherever you are in the world. Until next time, sleep well.